I'm Rityunjay Prasad, and this video is regarding finding critical points of a given functions and classifying its local maxima or minima. So this is the equation for which we have to find its critical points and then further classify the local maxima, minima, or check whether it's not having either of them. So first of all, we need to find the partial derivative with respect to x, which goes on as we know, like for differentiating with the two variables, we would take one with which we are with whose respect we are differentiating. We would treat it as normal differentiation, and the other variable should be constant. So here we will have as 2x minus 1, and then for fy we will have uh, 2y minus 3. So to find critical points, we have to take these two and equate it to 0. So when when fx is kept as 0, we would have 2x minus 1 equal to 0. That is simply we have x is equal to 1. So now we from here we have x is equal to 1. Then similarly uh, fy equal to 0. Therefore 2y minus 3 equal to 0. Then we have y equal to 3. So therefore from this and this, we have critical points. Critical point as 1 comma 3. Sorry, this is 3. Now to find whether critical point is local maxima, minima, or neither, we first have to find D. To find D, we use the formula f double derivative of the points, then f double derivative y, then the points minus f of b, and we do the whole square. We have this as our formula. Now using this formula we proceed further. Now finding f now finding f x, which is equal to, if we do this from here, fx is equal to 2x minus y. We would differentiate it again with respect to x. then we would simply here get 2, and we will get f y. Again, we would differentiate this expression with respect to y. Then here again we will get 2, and then we would simply uh, uh, then we would simply differentiate this expression again with respect to y. Now, since there is no y variable in this expression simply becomes to 0. So now what we have here, uh, left is this is equal to 2, this is equal to 2, and this, as we saw above, is equal to 0. Now simply d boil d boils down to 4. This means that d is greater than 0. And now, as we calculated fxx, a b is also greater than 0. This tells us that what we uh, what we had, that is fab, which is actually f 1 comma 3. These are the points of local minima. And now simply, if we put the critical points into the very above equation, which is this one, we would get the value of local minima. So now let us calculate the uh, value of local minima. Okay, so we had our function f1 comma 3, which is equal to 1 minus 1 whole square plus 3 minus 3 whole square plus 5. So simply 1 minus 1 is 0, 3 minus 3 is 0. Now we are left with 5. Now 5 is the value of local minima. Points of local minima is, we have this 1 comma 3, that is the critical point which we found earlier. And yes, and that is the question. We can revisit it. First, to find critical points, we took a derivative with respect to each variable, that is x variable and y as well. Then to find critical points, we equated the each of the two with 0, from which we got x as 1 and y as 3. That means we have our critical point as 1 comma 3. This is 1 comma 3. Now, to further see whether this critical point is local maxima, minima, or neither, we had to calculate d. And for that, we have this formula up here. And if we calculate double derivative of fx with respect to x, uh, we would get 2 2, and similarly with fyy we would get again 2, uh, we would get again 2. And when we uh, calculate this expression, we would simply get 0. We would simply get 0 as there is no y variable in this expression. So this all thing boils down to d is equal to 4, which is simply 2 into 2. uh, this thing suggests us that greater than d is greater than 0, and we have this greater than 0, which is 2. We know that it is greater than 0. This suggests us that the critical point we found is actually the local minima, and then simply putting the critical points in the expression, we would get the value of local minima, which comes out to be 5. And thank you.